One of the biggest challenges in selecting HVAC for this market is evaluating all of the different options available to you. And I'm going to try and break down a couple of them over the course of 2 videos here. The first of which is chilled water systems and why you would go with Agronomic IQ's unitary product versus a 4-pipe chilled water system. So just a brief description here of how we ended up in this position. Very early in this market, chilled water was largely not involved. As the market legitimized and legalization spread across North America, large growers were involving the engineering community, the general contracting community, and in very large facilities, the engineering group focused on what they knew. And large buildings, campus-level buildings, had typically been done with a central plant system, a chilled water system. What that means is they applied what they knew. There is no guidance even today from ASHRAE, for instance, on how to appropriately handle a controlled environment agriculture space. So engineers went with the knowledge they had. Large building, 1,500, 2,500 ton building, put a central plant in. That's how it's worked for your university campus or for a large office tower. It works, and they do work. But there's some very important caveats to that. In this case, I'm talking about a 4-pipe chilled water system. So that's a chilled water system that's capable of providing the cooling, dehumidification, and heating needs of a space. A 2-pipe chilled water system doesn't provide the reheat, and so there's a separate issue that needs to be dealt with there. So I'm going to stick to the 4-pipe system. But basically in a 4-pipe system, you've got a chilled water supply and return, and you've got a hot water supply and return. And as a result of that, your fan coils are distinctly more expensive than just a 2-pipe system, obviously enough. You've got 4 connections instead of 2 and 2 separate coil sets. But one of the biggest challenges with a chilled water system is getting your chilled water temp cold enough. One of the challenges at the space is the cool and dry conditions required at the end of a flower cycle, and that requires very cold chilled water. Typically 38 degrees Fahrenheit or so is required to achieve the dehumidification requirement of that colder time of the grow. Now, a 38-degree coil is going to produce very cold air, which means that you also need the reheat side. You need the hot water coil to bring that temperature back up, and you can't, obviously you can't be spraying 45-degree Fahrenheit air at your plant, so you need to reheat that back up, and that's where that 4-pipe system comes into play. Now, that has been a challenge in some of these facilities. Some of them haven't been running cold enough chilled water to provide enough dehumidification. That's a lesson that's been learned over time. But that reheat energy is a challenge in this space, and we'll talk about why in a second. What this does provide, though, is a properly designed 4-pipe chilled water system provides very accurate space control. Now, properly designed also means properly controlled. And when you're building a chilled water system like this, your central plant is custom designed for you. There is no package out there that is, a containerized setup or a default setup. You've got an engineer who's selecting a chiller or 2. We'll talk about redundancy in a second here. But chiller or 2, a boiler or 2, pump skids that are all separate systems, and then you need to layer a control system on top of that to make it all play nice together. So you need to control your chillers, your boilers, your pump skids, your pump energy, and then every fan coil in every room has a couple of different valves that are going to need to be controlled, and maybe even variable air volume to try and achieve some better dehumidification. So you've got a very complicated system, and redundancy here is expensive. Because you've got a central plant, you've got a central point of failure. If you've got one chiller and that chiller goes down, well, you've lost every room in your building, just like that. If you've got multiple chillers, well, if you've lost 1/3 of your capacity or half of your capacity, how do you manage your space in that way? And there's ways to do it, but it's something that you need to think about when you're looking at your overall space demands. And again, redundancy is expensive there. An extra pump, an extra, N+1 is typically the name of the game in achieving redundancy in central plant, which means that if you need 2 boilers, you've got 3 on site so that you've got a spare all the time. Same deal with chillers and pumps. And that redundancy adds immensely to the cost of that system because, again, you've got that central point of failure. It's probably one of the biggest challenges of a 4-pipe chilled water system. Obviously capitally intensive to do properly. Everything about a central system is going to be more expensive overall. And if you were to look at just your pure per ton cost of cooling, you're going to say, well, that's not quite true. I'm looking at the installed cost though. And we've compared equipment installed cost or facility installed costs across dozens of sites. And 4-pipe systems are expensive to install. You need a ton of piping. And in a big facility, you might be running 16 to 20-inch pipe for your chilled water side and your hot water side. And just that pipe, each foot of that pipe can weigh 300 pounds. So now you've got a huge weight to install. It's not quick to do. It's expensive to do. It's labor intensive. It all needs to be properly insulated to avoid having water issues or life safety issues around hot water pipes in your space. And the biggest advantage of a central plant is diversity. If you think about your typical office tower, for instance, only one side of that building is getting hit by the sun at any given point, which means that you may have a tower with 5,000 tons of fan coils installed, but that only needs a 2,000-ton central plant to achieve control to the entire building, because not every space is going to be demanding everything at the same time. Well, that's not typical of a controlled environment agriculture building. Your lighting schedule for your flower rooms is typically the same, whether it's all coming on at the same time, or you've got half your rooms during the day or during the night. Now, that's another issue we can talk about. But you negate the biggest advantage of a central plant, which is diversity. And it means that you need to install enough chilled water plant, enough boiler plant to handle your design day, and that design day is most days. The other thing, obviously, is low temp chilled water is pretty expensive to produce. If you were to look at the efficiency rating of a typical chilled water plant, it's producing 50 or 55 degree chilled water when they give you that kilowatt hours per ton number. That is absolutely not the case with 38 degree chilled water. It's going to be pretty brutal in terms of energy use. And you also have a 24/7 reheat requirement. I've been asked in the past, well, why don't we just turn down our chilled water plant for the last couple of weeks of the flower cycle when we need that additional dehumidification? That's not possible in this space. You've got a bunch of different rooms that are at various parts of the cycle. You're not going to run an entire facility on exactly the same schedule and plant week 1 and harvest week 10 and have nothing for your team to do in between. That's not how these facilities run, which means that you need that reheat available 24/7. You can't turn off your boiler plant. You can't turn down your chilled water plant. It has to be operating at design conditions 100% of the time. And that reheat energy is incredibly expensive. You've got a couple of options there, and one of the options are heat recovery chillers, but capitally expensive. They also don't produce very hot water. So a typical heat recovery chiller loop might be 115 or 125 degrees. Well, that temperature of hot water requires much more flow to achieve the capacity you're looking for, which means that your pump energy went up and your installed costs went up because your pipes did. Pipe size went up. So there's a huge expense to a chilled water facility that I think isn't well understood in this marketplace. And ultimately, even if we were to just look at the energy costs, you're typically going to spend 50 to 60% more in energy costs on an annualized basis with a 4-pipe system versus a unitary system. And it's for all those reasons, and I'm happy to discuss in more detail on a specific job, but it's for all those reasons that I feel 4-pipe chilled water systems are misapplied in this marketplace, and you've got better options out there.